where? Like, maybe at this top one, what did you put there?
CH3.
You put CH3? So you put this CH3, right?
Correct.
Okay, great. I'll take it. Then down here?
CH2, CH3.
Okay. And then what's left is H, right?
Yep.
Okay. Let me see if this makes sense. Yeah, I think this makes sense. So, looking down here, this is what Justin's imagining seeing. If he's looking down this particular bond, that the methyl group is up here, and then if you go a little bit down at the right, you get to the ethyl group. You keep going here, you get to this hydrogen. Okay, that works for me. Then let's see what you put on the back one, and this will tell how well you did here. What did you put in this bottom position?
pH.
pH. Okay. I'll take it. Okay, here.
H.
All right. And then Br. Right? So you line these two up on purpose, right?
Yes.
Okay. And let's see. I'm just double checking your work here because it does matter where these three groups go. This is a chiral center here. So for looking down this particular bond, Justin's imagining the bromine going up, the phenyl coming down, and the hydrogen going up and to the left. So I like this a lot. It's different than how I would have done it, but I might have had the hydrogen here and the bromine here. And so if other people have different drawings, it's perfectly normal. But the thing I want you to double check is maybe looking at this front carbon and going the clockwise direction. Do you have hydrogen, methyl, ethyl? If you have that, you did it perfect. In the back, it doesn't matter where these three groups are, as long as you have them in this order: hydrogen, bromine, phenyl, going clockwise. So if you had anything like that whatsoever, whoever else is out there, perfect. Okay, great. So these things come together, and then how would you, Justin, if you're still here, I'm going to draw on the substituents on here, but would you label this stereochemistry as E or Z in your product?
I was a little stumped on it, but
that's okay. Just take a guess.
Most likely
E. Okay, E. We'll get to it. All right. So what I'm going to do here is the two carbons that are important. The mechanism works perfectly like this. Justin decided to, thanks so much, Justin, to put these two groups 180 degrees apart. I gave us a clue that there's only really one that possibly could react. There's only one beta hydrogen. They line up like this in the perfect anti-conformation, and the double bond starts forming right down the middle. So at one carbon, the front one, we'll have a CH3 group, and a CH2, and a CH3. It's all these. And then in the back, we're going to have a double bond. And we should have H and phenyl on that other one. So I don't know if this is what Justin had, but you labeled it E. It's okay. We'll get to exactly what this is momentarily, which of the two stereochemistries this would be. So does anyone want to stop or back me up right now? Or did you draw something else, did not get to this level of understanding? Again, you can have a different Newman projection picture, but you should have these two groups opposite. But again, it might be the whole thing might be rotated or moved. But again, if you got it right, if these two are opposite, and if when you're reading it from clockwise, you go hydrogen, methyl, ethyl, hydrogen, methyl, ethyl. That's what I see when I look down this bond, or hydrogen, methyl, ethyl. It sounds like a crazy person speaking, but this is what you get from me, all right? Looking down the back here, we'd have hydrogen, bromine, phenyl going clockwise, or bromine, phenyl, hydrogen, bromine, phenyl, hydrogen, bromine, phenyl, hydrogen. So again, I'm just trying without looking at all your work, which is impossible, to talk you through to know if you have it right or wrong. Didn't even have this wrong, didn't get it, need some help with the transcription that me and Justin just went through, just, by all means, speak up right now. We can redraw it, but now's a good chance. Or, we might have a chance again in office hours. If anyone wants to speak up, now's a good chance. Okay, we're going to keep going. I'm going to assume that you guys are all following along fine. So these two groups end up on the same side. We can see them forming. If a double bond forms right down the middle, these two will be on the same side, and these two groups that don't react will be on the same side. And phenyl is just a benzene ring, so we have priorities on this particular side, and this is the priority, phenyl versus hydrogen. And ethyl versus methyl, which is the priority in easy nomenclature. It's the ethyl group that's higher priority. This carbon is attached to two hydrogens, so is this one. And then finally, the third attachment here is the hydrogen, but the third attachment here is the carbon. So this carbon here breaks the tie between these two groups. And these two things are together on the same side. So it's Z or zusammen means together. So thanks for speaking up and just taking a guess at this, Justin. But hopefully that resolved the issue. Hopefully this is the structure you had. And then the EZ was just a matter of how to, go back to that stuff that you did a few weeks ago. Okay. I'm going to fill in one other thing here, and that's the mechanism. for this reaction. And the mechanism, if we were just going to draw it, I'll use a black pen. This base attacks this particular hydrogen. This pair of electrons starts to form a double bond, and this group leaves. And from this particular picture here, it would be almost impossible, I think, to draw the correct E or Z with 100% accuracy, which is what we would want. Okay, we want 100% accuracy for this. So I think we really kind of need this particular picture. But at the very least, you could have had a double bond here, and on one side you should have hydrogen and phenyl, and on the other side, I'm going to draw squiggly lines, meaning we're not sure where the groups are. But to a first approximation, you should have something that looks like this. I just happened by on accident, honest accident, to draw the right enantiomer, or the right stereoisomer here, but we wouldn't really know from this particular picture which way should these groups be. Okay, in my opinion, anyway. So this is actually a very, very difficult problem, very, very complex, high-level problem. Not all the problems are going to be like this, but this particular problem is the highest level we could strive to achieve in understanding this. We could form a little bit of the E isomer, but it'll be highly, highly unfavored. Why don't you guys take just a few minutes here? I want you to draw the Newman projection. I should draw a Newman projection here that would lead to the E isomer. Okay, so I'm just going to draw the front. You're going to have to rotate the back carbon. So let's leave the front the same, just like Justin did. H, ethyl, methyl. There's only one beta hydrogen. It's this one. So there's not another one that's going to give us the other enantiomer. So what would your Newman projection look like to get to another reactive conformation? We need hydrogen and bromine, alpha and beta to one another. They are. And we need them either 180 degrees anti, or we need them 0 degrees in syn. Draw the syn conformation where bromine and hydrogen are syn here. See what you come up with if you remember how to do this for Newmans. Just take a little bit of time. Try and draw what you think that would look like. You might have a rough go at it, but what conformation, what would it look like? What would the other substituents be on here if I rotated this back carbon atom 180 degrees to make bromine and hydrogen syn to one another, 0 degrees disposed? Just sketch whatever you think I'm trying to express to you. Come up with a sketch. What do you think that means? If they're syn to one another, that means it's going to have to be an eclipsed conformation. And I want bromine to line up with hydrogen. So I'm going to rotate it 180 degrees. In my mind, I'm going to go counterclockwise. Bromine's here. If I bring this 180 degrees counterclockwise, then where's phenyl going to go? Right? If bromine comes over to hydrogen and it becomes eclipsed, then if phenyl goes 180 degrees clockwise, it should be eclipsed with this methyl group. And then this hydrogen, if we rotate 180 degrees, it should become eclipsed with this ethyl group. So this would be the syn conformation, or the conformation in which these two groups are 0 degrees disposed to one another. And this conformation would also work and be reactive. This is favored. This is unfavored. And this could give a tiny amount of the E conformation. If base pulls off this proton, double bond starts forming here, and bromide leaves. Imagine this whole part of the molecule is getting plucked off, and the molecule is flattening out. Right? Molecule will be flattening out, and there'll be a double bond here. We actually draw it. We actually flattened this molecule out, took off the beta hydrogen, the leaving group at alpha, started forming a double bond down the middle. The phenyl and methyl group would be on the same side. The hydrogen and ethyl would be on the same side. And here we would have the E stereochemistry. Again, this group is favored, this group is favored. They're on opposite sides of the E stereochemistry. This is the major product, formed actually 100% yield. This is formed in 0% yield. Look at the energy difference between these two conformations. Look at the energy difference. Which of these two would be more stable? Would it be more stable by a little bit or a lot? Well, this is definitely more stable. It's the staggered conformation. And we have a bunch of potential Gauss interactions. Maybe one here, maybe one here, maybe one here. So there's a few little penalties that would add up, but you recall those Gauss penalties are tiny compared to H bromine eclipsed, H ethyl eclipsed, methyl phenyl eclipsed. These are all eclipsed interactions. They have huge penalties. There's huge tables to look through. Maybe you spent a little time with Dr. Marina's doing that. So this particular conformation just doesn't really form. And this particular high-level difficult example, this is the sole product we get to. Okay, so thanks for working with me on this. This is difficult, and we're going to back off now to some slightly easier problems to finish off the lecture. But this middle portion of it is the most challenging, and study it to the best of your ability. Do you guys have any questions at all about what we've